Welcome to aminacademy.com. In physics, let us discuss about mechanical property of solids. Before that, we will discuss about what is solids. Solid is one of the four fundamental states of matter, that is, other being liquid, gas, and plasma. The molecule in a solid are closely packed together and contain the least amount of kinetic energy. A solid is characterized by structural rigidity and resistance of force applied to surface. Unlike a liquid, a solid object does not flow to take on the shape of container, or does it expand to fill the entire available volume like the gas. That means solid is not expanding in the container. It how much it fill, that much it shows. The size will not change. The atom in a solid are bound to each other either in a regular geometric lattice, that is crystalline solids, which is include metal as metal in ordinary, that is ice, or irregularly an atmospheric solid such as common window glass. Solids cannot be compressed with little pressure, whereas gases can be compressed with little pressure because the molecules in a gas are loosely packed. Further, we'll discuss about a solid. Solids are made up of atoms or group of atoms placed in a defined geometric arrangements. This arrangement is decided by nature so that the resultant force acting on a force constant due to others is zero. This is the equilibrium state of a solid at a room temperature. The given equilibrium arrangements does not change with time. It can change only when on external stimulus, like compressive force from all solids is applied to a solid. The constituents vibrate about their equilibrium position even at very low temperature but cannot leave their fixed position. This fact provides the solids a definite shape and size. If an external force is applied to a solid, the constituents are slightly displaced and restoring forces are developed in it. These restoring forces try to bring the constituent back to their equilibrium position so that the solids can regain its shape. When the deforming forces are removed and interatomic forces tend to restore the original positions of the molecules, and thus the body regains its original shape and size. However, as well as we will see later, this is possible only within certain limits, because if more force is given, this is a break, that solid will break. What is deforming forces? The change in a shape or a size or both of a body due to an external force is called a deformation. Now, further discussion, deformation of a solids. The shape of an object is the geometrical description of the part of the space occupied by the object as determined by its external boundaries. A change in shape due to the application of a force is known as deformation. Even small forces are known to cause some deformation. Mostly with the less forces, the shape after removing the force, the shape regaining original. Now, elastic behavior of solids. In a solid, each atoms or molecules surrounded by neighboring atoms or molecules. These are bounded together by interatomic or intermolecular forces and stay in a stable equilibrium. When a solid is deformed, the atoms or molecules are placed from their equilibrium position, causing a change in their interatomic or intermolecular distances. That means some deforming force is applied, this intermolecular distances vary. When the deforming force is removed, its atomic force tend to drive them back to their original position. Thus, the body regains the original shape and size. The restoring mechanism can be visualized by taking a model of spring ball system. Here, the ball represents atoms and springs represent interatomic forces. This is a spring ball system. If you try to displace any ball from its equilibrium position, the spring system tries to restore that ball back to its original position. Thus, elastic behavior of solid can be explained in terms of microscopic nature of a solid. Next, stress and strain. Before that, elastic behavior, further in this case, if a body regains its original shape and size after removal of their deforming forces, it is called an elastic body, and the property is called elasticity. Here, the restoring force are strong enough to bring a displaced molecules to their original position. Example of elastic material are metal, rubber, quartz, etc. If a body regains its original shape and size completely and instantaneously upon removal of the deforming forces, then it is called a perfectly elastic. That means after removal of forces, it's completely come to the original position. If a body does not regain its original shape and size and retain its altered shape or size upon removal of the deforming force, it's called a plastic body. That means after removal of deforming forces, that the body is not completely come to its original position. It's called a plastic body, and the property is called plasticity. Here, the restoring forces are not strong enough to bring the molecules back to their original position. Example of plastic materials are clay, putty, plasticine, thick mud, etc. There is no solid which is perfectly elastic or perfectly plastic. The best example of near ideal elastic solid is quartz fiber, and that of a plastic body is putty. Now we'll discuss about stress and strain. Here, stress is a force applied to a material divided by the material's cross-sectional area. Strain is the deformation or displacement of material that results from the applied stress. Suppose look at it's a solid bar is there. If you apply a compressive force, so while applying compressive force, that is the material gives some opposing force not to compress. It's called a stress. If the force is more and more, it compressed. Now, stress formula is force by cross-sectional area. Stress formula is sigma equal to F by A. Here, sigma refers to the stress. F is the force applied and A denotes the area of the surface. Stress formula is used to find stress applied on any given body if force and area on which force is exerted are provided. Now, further discussion about stress and strain. The elastic properties of a body are described in terms of stress and strain. When a body gets deformed under an applied force, restoring forces are set up internally. They oppose change in shape or size of the body. When body is in equilibrium in its altered shape or size, deforming force and restoring force are equal and opposite. The internal restoring force per unit area of your body is called a stress. Now, strain is a measure of deformation of your body. That means how much it's deformed. When two equal and opposite forces are applied to an elastic body, there is a change in the dimension of the body. Stress is defined as the ratio of change in dimension of the body to its original dimension. That is, strain equal change in dimension with original dimension. Now look at here. Strain is the deformation of a material from stress. It is simply the ratio of the change in length to the original length. Deformation that are applied perpendicular to the cross section of the normal strain, while deformation applied parallel to the cross section and it becomes shear. Now look at here. This a body length L is there. Suppose we are applying a pulling force in both end, so its length become increased. So that delta is the increased length. That means how much it's increased divided by the original length of the body is called strain. Strain is the ratio of change in length to the original length when a given body is subjected to some external force. Strain equal to change in length divided by the original length. This is the strain formula. Next here, tensile stress or compressive stress. Tensile stress. It is the equal force applied to a body perpendicular to its cross-sectional area to deform it. Compressive stress definition is the solid is compressed by applying an external force. In response, the restoring force is produced in the body, which is known as the compressive stress. Here, look at here. This is a compressive force. This is a tensile force. Here, due to compressive force and tensile force, something happened to the body shape. Tensile strain is defined as the deformation or elongation of a solid body due to the application of tensile force or stress. In other words, tensile strain is produced when a body increases in length as applied forces try to stretch it. The tensile strain can be expressed mathematically by the formula E equal delta L by L, where E equal to tensile strain, delta L equal to change in length, L equal to original length. Here the tensile stress is the ratio of both equal things. That means what? Here also length, here also length. There is no unit on the unit for tensile stress. Here, therefore, the tensile stress have no dimension. Further, in forthcoming videos, we will discuss about compressive stress and further about bulk modulus, tensile strain, volumetric strain. Then further things we'll explain in next videos. We have done. Please subscribe our YouTube channel.